So this is the numerical associated with the saddle support. A horizontal vessel has 1.8 meter diameter and 8 meter tangent to tangent length. The vessel has elliptical head with major axis to minor axis ratio of 2.0. The pressure inside the vessel is 1.5 kgs per centimeter square and the shell thickness is 8 millimeter while the head thickness is 10 millimeter. There is difference in the shell thickness and the head thickness. Then the permissible stresses of the material is 1060 kgs per centimeter square and the weight of the vessel with its contents is 21,500. That is nothing but the reaction and the support. So reaction and the support also you can take because this weight has to be balanced by the two supports. So the reaction and the each support, that will be 21500 divided by 2. So the distance of the saddle center line from the shell end A, that is 380 millimeter. Calculate the bending moment induced and the stresses induced in the vessel. Instead of these stresses, we are only calculating the longitudinal stresses in this vessel, in this numerical. So the horizontal vessel with two elliptical heads can be considered as an equivalent cylinder with length equal to L plus 4 upon 3 into the H. And in this case, the depth of the head that is taken as the diameter upon 4. 1/4 of the diameter, depth of the head that is taken as 1/4 the diameter of the vessel. So 1.8 divided by 4, that is nothing but the depth of the head. So then the weight of the fluid in the vessel can be considered as uniformly distributed load on the equivalent length एवढे. So two symmetrical support shells to be provided and each will carry a load of W by 2, so that is 21500 divided by 2 and which will have the value of 10750. And A is nothing but the distance of the saddle center line from the shell end. So this is the saddle center line and the so this is nothing but your A value. This is A. Then 1 minus into bracket 1 minus A, that is 0.38, that is 380 millimeters, divided by L, that is the length of the vessel is 8 meter, that is what is mentioned. Then H is nothing but the depth of the head, that is taken as 1/4 the vessel diameter, that is 1/4 the vessel diameter, that is mentioned as 1.8 meter. So that is the 0.9 square minus 0.45 square into the upon 2 into AL, 2 into the A into the L. So this comes M2 as the 845.6. So M2, that is nothing but the bending moment at the support. Similarly, you have to calculate the bending moment at the center, that is nothing but the M1. So this is the bending moment induced at the center of the vessel, that is M1. You are having the formula and the M1, which is nothing but the Q into the L upon 4 into bracket 1 plus 2 into the R square, that is 1.8 divided by 2, and this is the H square that is the 1/4 the diameter of the vessel. So this is also H upon L minus 4 into A upon L. So this is how the bending moment at the center of the vessel that will be calculated, and its value comes as to be 16,297 kg meter. The next is the stresses calculation. So stresses calculation at the topmost section, cross section of the vessel, topmost cross section of the vessel. So that is the M2 upon Z, K1 into Z, and Z is your pi by 4 into D square into T. So substituting all this value, its value comes as 4.15 kgs per centimeter square. Then next is longitudinal stresses at the bottommost cross section. So this incorporates the M1 value, and it is the M1 upon K2 into pi by 4 D square into T. So its value comes as the 80 kgs per centimeter square. The next is the stresses induced at the mid span of the vessel, and this also includes the M1 value. So F3, which is equal to M1 upon pi by 4 D square into 2 into T, that also comes as 80 kgs per centimeter square. And in addition to that, the longitudinal or axial stresses that will be also exerted because of the internal pressure of the vessel. So for internal pressure of the vessel, the stresses will be calculated as PD upon 4T, and which comes as 92.8 kgs per centimeter square. So all these stresses are to be added, 92.8, then 80 kgs per centimeter square, again 80 kgs per centimeter square, and previous to that it is 4.5 kgs per centimeter square. So it is around no, 36, that is 300. So permissible stresses mentioned here is 1060 kgs per centimeter square, and it is around only 300. The summation of that will be not more than 300. 254 or so, whatever the total will be. So this is less than the permissible stresses of the material. So that is what, all these stresses are considerably less than the permissible stresses of the material.